All right, guys, somewhat of an exciting one today. So we're checking to see what happens as, if you have the nth term of a sequence, like we've got here, as n goes to infinity, or in other words, as the sequence goes on forever and ever and ever, what would be its limit? What would it eventually become is what we're looking for. And sometimes that's not so easily apparent. So we might have to reduce what we've got. In this case, we reduce what we've got here to make that happen. So what would this become if this sequence went on forever? If it was going on to infinity, what would this become? That's the question that we're trying to find out. What would be its limit? What would be its end point? Okay, now that we've got that in our head and you're thinking about it, let's now start thinking about what would happen and what we need to do to make that happen. And what we actually need to do in this case, to start thinking about what will happen as n gets very large, we want the limit as n goes to infinity. That's really what we're looking for here. And to do that, what we want is the highest power of n. We want the highest power of n and ignore any constants. So like, for example, this is a constant here. We'll completely ignore that generally, because even if you're going all the way to infinity, that one is never going to change. You're always going to be adding one, adding one, adding one. It's never going to change. So we'll ignore it and just take the highest powers of n for both the numerator and the denominator. So what we'll end up with is 6n divided by 2n, completely ignoring this 1. And then you just simplify what you've got. So 6n divided by 2n, what will happen is the n's will cancel out, leaving you with just 6 over 2, which is going to be equal to 3. So basically what we're saying is, as this sequence goes to infinity, as you have an infinite number of terms in the sequence, it will all get smaller and smaller and smaller, and it will round itself off to the number 3. And that's it. That's the general idea behind it. Now time for us to put it to practice in some other questions. So here's our second example. And again, all we need is the highest power of n. That is all we need to make this work. All right, so the highest power of n. Let's go. That means that we're going to keep this. We're going to completely ignore that because that's not the highest power of n. And remember what I said about constants. We don't need any of the constants at all. So that gives us then n square divided by n square. Once you just take the highest power of n in the numerator and the denominator. And basically you've got the same thing divided by the same thing. So this is going to bring itself down to 1. So if this sequence was allowed to carry on to infinity, as n approaches infinity, then this sequence basically converges to 1. All right, you getting the idea? I hope you are getting the idea. Let's try another one. All right, here's our third example to look at. And if you want, you can pause the video. Feel free to do so and have a go on your own. But I'm going to go straight for it. So again, the highest power of n in the numerator, the highest power of n in the denominator. And bearing in mind, it wouldn't always be n. Sometimes it could be x's, but we're dealing with n's today. So this then gives us n divided by n square. We completely ignore the constants that we've got there of 7. We simplify this using your indices or your laws of indices or whatever it is you want to use, but you'll end up with 1 over n. Okay, obviously that will cancel out, and it cancels out one of the n's down here, so 1 over n. And we're not finished, because we would like to find out what would actually happen. Well, we've got a very, very simple fraction of 1 over n. Now think about it. If n is going to infinity, we all know that the bigger the denominator of any fraction gets, the smaller the fraction is actually getting. So this then is actually going to 0. So it means that if this was allowed to go on, it will be tending towards 0, or it will be converging to 0, because obviously the bigger the denominator gets, the smaller the fraction is getting. Okay, one more example. Okay, this is going to be a bit of a lengthy one, so this is our final example on this. And for this one, we're doing exactly the same thing. We need to work out the limits of this sequence. If this sequence was allowed to go on, what would be the limit of this sequence? Where is it going to be converging to? Well, you might be looking at the fractions and thinking, oh, can't be bothered to work that out. Well, it's not really that difficult. Do the numerator first and then do the denominator. So I will put n for numerator. So I'm doing the numerator first. The sequence is 2, 3, 4, 5, 6, and so on. And if you know how to work your sequences out, this is clearly going up in ones. So it's going up in ones. So therefore, that's just going to be n. We find the term that comes before this. So the term that comes before would be 1. So basically the nth term of the top would be n plus 1. Do the same thing for the bottom or the denominator. I'll put a d for denominator. Your sequence is 5, 6, 7, 8, 9, and so on. And again, this is also going up in ones. Okay, so if this is going up in ones, it means that we'll have n straight away. Find the term that comes before. It will be a 4, so then it will be n plus 4. So basically, the nth term of this sequence then is going to be n plus 1 at the top and n plus 4 at the bottom. Now we can find out what would happen as this goes to infinity. Well, do the same thing we were doing. Take the highest power of n at the top, the highest power of n at the bottom, and we will end up with n over n, again completely ignoring the 1 and the 4. And this obviously works out to be 1, so it means that as this sequence goes to infinity, then it converges to 1. And that's it. Simple, nice, quick, and easy on how to work out this, the limits of a sequence. Obviously, you're going to face more and more challenging questions, but persevere with it, follow the rules, and you should be fine. All right, so if you've got any questions, let me know. But that's it for now.